Good evening. Today we are going to cover the two question actually not two questions. One of the question we covered earlier in the assignment number 6, which is the robot utilization calculation. Now remember I told you that I'm going to give you a simple way to do that, and just today I submit a blank paper with some lines, so you can, well actually it's tables, so you can use it in the final exam to do the solution for this question if you are going to have it. So first we are going to start with the industrial robotic, and in this slide we are going to explain and discuss the most effective method to calculate the cycle time TC, the robot utilization time and the robot utilization percentage. So this was question number 2 in the assignment number 6. So we mentioned here that we can use either the equation method, the one you had in the example in the class, but the problem with this one that we should have the traveling percentage should be equivalent. For example, we had the time travel from point to point is A or 2A or 3A and extra, but in the question you had in the assignment we had different values, and this will make it harder if you are going to use the equation thing, because most of the time will be spent trying to find a relation between the traveling times. So in the case number 1, we said that the station is going to be manufacturing just one part on time. So the cycle starts from picking the part at the input point. So we are going to pick up the part number 1, travel from the input to the machine number 1, put down the part at machine number 1, we start the processing. After a certain time we are going to finish, so we have to pick out the part, travel it to the machine number 2, put it down, machining at the part number 1 at machine number 2, pick out the part number 1, traveling to the output point, put it down at output point, and then we have to travel back to pick another part and repeat the cycle. So if I'm going to tabulate in the sequence number 2, we can use both machines at the same time. That means we are going to have extra movement for the robotic arms. What happened is that at the minute we are going to finish the machine at the machine number 1, get rid of the part and get a new part and put it on the machine number 1. So machine number 1, machine number 2 are going to be busy at the same time, and the robot is going to make more traveling to pick and put down the parts on the both machines. So we can simply pick the part and do step number 1 to travel to the machine number 1. After machining at the machine number 1, we pick out the part and do the second trip to the machine number 2, put it down there, and we have to go back to the input point, pick a new part, make the movement number 4 to put it on the machine number 1. travel back to the machine number 2, waiting for the part at machine number 2 to be done. Take it up and put it to the outer point. From outer point, we travel back to the machine number 1, waiting for the part to be finished. Take it up and move number 8, which is going to take it to the machine number 2. Then we have to travel back to the input point, pick the third part, and continue the process. Do the step number 1, 2, and 3 continuously. To make a table for that, I only just put the table where we're going to start with the part number 1 and finish with the part number 2. I didn't continue the full table because it's going to be too long. I think this will be something about 30 to 35 steps, and this will make it very easy for you to do it in the exam. Now, I would like you to get a full mark for this question, because nobody did in the previous year, because nobody got the chance to have a full explanation of this example. So to summarize the table, first pick up the part number 1 at the inlet point. Then travel to the machine number 1. Put it down at machine number 1. Start the machining at the machine number 1. This time will be added, because actually the robot is waiting. Don't do any movement until the machining is going to be finished for the part number 1. Pick up the part number 1 from machine number 1. Go to the machine number 2. Put down the part at the machine number 2. We start to have the machining at the machine number 2. Now you can see that the time is 17.4, but actually this time is not going to be added. You can see that we had 11.4, but the machine will, the robot will simply travel to the input point once again and pick up another part. So we're not going to use 17.4, 11.4 plus the traveling time to the input point. This will make 11.9. And then we are going to pick up the part number 2 from the input point, and this will take something about 2 minutes, and this will make it totally 12.1 minutes. Travel with the part number 2 to the machine number 1, put it down there, start the machining. Now, till this moment, you can see that the machining of the part number 1 at the machine number 2 is going to last for 6 minutes, while the machining of the part number 2 at the machine number 1 is going to last for 10 minutes. So the best option is to travel back to the machine number 2 and wait for the part number 1 to be finished. So the next step is traveling to the machine number 2. So as we said here, as the machining time at the machine number 1 is 10 minutes, so thus the machining of the part number 1 and machine number 2 is going to finish first. So step 14 is going to be travel to machine number 2. Now, the trick is how to calculate the waiting time. Now, you can see that at the minute we put the part number 2 at machine number 1, it was 12.6 minutes. Then we spent first 23 minutes to travel to the machine number 1. So starting from putting the part at the machine number 2, and this will make it the step of the first yellow one. You remember the 11.9 minutes. Then when we travel from the machine number 2 to the input, 0.5, pick up at the input 0.2, let's make it 0.7, travel to the machine number 1, 0.3, let's make it 1 minute, then put it down at the machine number 1, and this will make 2.2 minutes, let's make it 1.2 minutes. Then we travel back to the machine number 2, and this will make it something about 1.5 minutes. So totally, since we left the part at the machine number 2, we spent 1.5 minutes. The machining time at the machine number 2 is 6 minutes, subtracting, and we're going to have 4.5 minute waiting time until the part number 1 to be done on the machine number 2. So the travel time from machine number 1 to 2 plus the pickup at the input, traveling to the machine number 1, putting down at the machine number 1. This one is repeated. The traveling time from 1 to 2 to be added, and by adding all these times we are going to have something about 1.5, and in this case the waiting time is going to be 6 minutes with the machining time at the machine number 2 minus 1.5, and this will make it 4.5 minutes. Finish with the part number 1 at the machine number 2, pick up the part, travel to the output, put it down at the output, travel back to the machine number 1. Now in this case we didn't travel back to the input because the machine number 1 is still busy doing the part number 2. We have to wait at machine number 1 for certain waiting time. Now let's check what will be this waiting time. So since we left the part at the machine number 1, we spent 0.3 minute traveling from machine number 1 to machine number 2. Waiting time for 4.5 minutes at the machine number 2. This make it 4.8. Plus 0.2, which is pickup time at the machine number 2. This will make it 5 minutes. Traveling from machine number 2 to the output is 0.4. Let's make it 5.4. Putting down at the output 0.2. And then we have to travel back to the machine number 1, and this will make it 5 minutes. So totally we are going to have 6.1 minutes has been spent since we left the part at the part number 2 at machine number 1. So the waiting time is going to be 10 minutes minus 6.1, and this will give us 3.9 minutes. So you can see that on the side we just added up the time, and till now we spent 22.6 to manufacture the parts number 1 and finish the part number 2 at machine number 1. So pick up the part from the machine number 1, travel to the machine number 2, put it down at the machine number 2, and we start the processing there. Now we have to go back to the input and pick another part. Okay, machining process number 2. Okay, and then we have to go back to the input point and pick the part number 3. Pick part number 3, take it to the machine number 1, put it down at machine number 1, start the machining of part number 3 on machine number 1. Now we are going to redo the same sequence back to the machine number 2, waiting time for 4.5 minutes. Pick it up when it's finished and travel to the output point, put it down, and go back to the machine number 1 to continue the process. And then we can continue the process for multiple parts as we like to. Now how to find what will be the cycle time in this case. Now because we finished part number 1 and part number 2, simply if I'm going to take the total time when we left the part at the output point, which is the 30.1, and we go to the previous point when we put the previous part at the output point, we go up, and this will make it 18.2. If I go to subtract 30.1 minus 18.2, I'm going to have the time of the cycle work, and this will make it 30.1 minus 18.2, which is going to be equal to 11.9 minutes. So the cycle time to start producing the part after the first part is going to be 11.9 minutes. If you continue doing this table till the end, then you will find that the time is going to remain the same. Now I'm sorry that this lower bracket is only 30.6. Actually it should be at the 30.1. Now to find the robotic time, the same cycle time minus the waiting time for each part. So this will make it 11.9 minus the 4.5 waiting time at machine number 2 plus the 3.9, which is the waiting time at the machine number 1. And this will make the total time while we utilize the robotic arm for each part is going to be 3.5 minutes only. Now once again, you can find the robot utilization, which is going to be 3.5 divided by 11.9. Making more parts will simply increase the utilization of the robot. Now I think this will be enough for this example. I think we have only one point about one of the parts number C in the question we had in the assignment is how we can increase the production rate and minimizing the robot movement simply if we are going to use what we call double gripper. Now you can see that this one is holding two parts. Now consider that the one on the right is part number 1, the other one on the left is the left is part number 1, on the right is part number 2. So we put the part number 1 and we don't have to travel to the other machine to pick the part. So simply when we finish the machining of the part number 1 on the machine number 2, we pick it up, then the robotic arm will rotate and leave part number 2 and travel to the machine number 2 to finish the process. Now the other example I would like to discuss with you today is about the G coding. Now the most important thing is these talking about something about 8 codes, G codes and the M codes. That's actually, you have to memorize this one because I don't think it's very complicated. G00 is rapid feed. That's mean we're not going to do any cut. M03 is spindle start in the counterclockwise. The G01 is a linear movement with cutting, and M02 is going to be program stop and spindle to be stopped. G02 is a circular movement in the counter. It's going to be G2 is the clockwise direction. M30 is the end of the program. G03 is circular movement in counterclockwise direction, and G05 is ideal. For example, stop and wait to do changing the tool or changing the part. So this figure, I gave it as a final exam question for another school. The one you are going to have is totally different, so you don't have to worry about this one. But the most important thing with this one, we are going to have inside and outside cycles. So the circles, that's mean you are going to do clockwise and counterclockwise cutting. The other thing, we have some edges, and this will make it a little bit hard task to identify where we are going to stop the parts. So you can see here that we have two lines. The first one is the black one and the other one is the blue one. You can see that we had arrow on the blue one. That means this will be the tool path, while the one we had, the black one, this will be the cutting path. That's what we like to have at the end of our cutting process. Now, the offset of the blue line from the black line is the value of the radius of your cutting tool. In this example, I didn't identify what is the diameter of the cutting tool, but you can assume anything. For example, let's say it's going to be, the diameter is going to be 10 millimeters. That means that the offset is always going to be by the value of 5 millimeters, inside or outside. So first, this is my cutting tool. This spread circle with the center point in the middle. Now the center point is very important for me because this will decide where I'm going to move my cutting tool. Always the center point will be moving along the cutting path. Sorry, the tool path. The red line is always going to be in contact with the cutting path. So how to find my first point? Now this shape is quite tricky because what we're going to have is we're going to set our 0 point in different position than the one we used to do. We said always that our 0 point is going to be at the bottom left corner at the top surface of our work part. In this case, it's very hard to put it there because it's going to be somewhere in the air. So the best thing is to choose another corner, which will be this one. So first, I'm going to go with a line up, which is equal to the radius of my cutting tool. then I will go to the left with the same value of the radius. Now, what I got here is my center point, the first point of my cutting tool. So I'm going to move to this point. I'm going to use the G00 from the home point. I don't have to mention the home point to this point. So first, to start a program, first you have to write down M03. Then you are going to define, for example, what will be the spindle rate. Let's say it's going to be 1000. Then the second line is going to be G00. You don't have to identify the origin point. You have to identify the final point. And in this case, it's going to be, for example, consider this one is my 00 point, is the one at the bottom. Task is going to be, let's see, this one is 50, then we have the radius 50, so it's going to be down at the page. Okay, 50, 50, and this point is going to be 100 plus 5, 105, and then we shift to the -5 for the x. So x is going to be -5, the y is going to be 105, and the z is going to be equal to, let's for example, 10. So my first line after starting the spindle is going to be G00, y, x is -5, y is 105, and the z is equal to 10. So this will be the new position of my cutting tool. Now, I'm going to do the cutting in counterclockwise. That means that my next movement is going to be downward, but first I have to penetrate my cutting tool into the work part. So my next cut is going to be G01. The x and the y will remain the same. The z will be equal to, let's say, -10 if the thickness of your part is 10 millimeters. The next step, I have to do the profile cutting. So I will go downward to the next point, which is at the end of this arrow, and this will be simply equal to G01, that's for the penetration, then G01 in a straight line to the new point. To find the coordination of this one, we go up by 50, then we -5. So what's happened is that the x value will remain the same, the z value will remain the same, the y value is going to be equal to 45. So the fourth line is going to be G01, y is equal to 45. Then I have to make a circle cut in counterclockwise. And in this case, I have to choose the order of G03. Now, G03, and just write down a line to take it to the third position here. It's not the one at the middle, because simply we can cut as 180 degrees. It's very simple by using the R code. You don't have to write down the I code, I and J code. So simply it's going to be G03. In this case, we are going to change the x value. It's going to go to the other side. It's going to be something about 100, because we are going to add radius of 50 plus another radius of 50. We were at -5, it doesn't matter, because what we are going to care about is the end point, the center point of the fourth cycle you can find here. So simply we are going to write down that G03, x is equal to 105 in this case, and the y value will remain the same, but you have to write it down. So the y is going to be 45. The z is not going to be changed, but we have to write down the r value. Now, because we are cutting from outside, that means that the r value is going to be 55. It's the radius of the blue line, blue arc, so it's going to be 55. Now I have to go back to the G01 to do the cut for the other side, to the right side of the profiling, I have to go up to the end of the arrow with G01. Now why the end of the arrow? Because in this case, when I'm going to do the arc, I'm going to keep this corner clear. If I'm going to take it closer, I'm going to damage the work. I'm not going to have the same dimensions. So G01, the X value will remain the same, but the Y value will be 105. So this will be the new line. G01, Y is equal to 105. Now I'm going to have another arc to take it to the end of the arrow of this arc, to this point. So this will be G02 because I'm going to turn in the clockwise direction. To do the clockwise direction is going to be G02. Now you can see that both X and Y value are going to be changed. So to find what are the data of this point, simply I'm going to do a simple calculation. Now for the X is going to be 55. Now tell me, how did I got the 55? Because at the center of this circle in the middle is actually, we have 50, which is equal to the radius of the biggest arc at the bottom. So that's 50. But I have to shift a little bit to the right, which is equal to 5 millimeter. So that's mean that my X value is going to be 55. Now my Y value is equal to 50 for the radius of the bottom one, plus 50 for the height of the middle part, plus 50 of the part of the arc we are going to have at the top. That means that the Y value is going to be 150 plus 5, so the Y value is going to be 155. The R value in this case, because we're doing the inner cutting, is going to be 50 minus 5, and this will be the arc of the blue arc, the radius of the blue arc, which is going to be 45. So the next line is going to be G02. X is equal to 55. Y is equal to 155. And R is equal to 45. Now, to do the other arc cutting, we have to move to the left. Now, G01, and I'm going to move it to the other side. Now, in this case, maybe this drawing is not accurate because actually the two circles should be in contact. But anyway, the X value in this case is going to be equal to 45. So G01, you have to write down G01 because we're changing from G02. G01, X is equal to 45. Then we have to make the last arc, and in this case we're going to use G02 once again, and the R is going to remain the same, and our final destination is going to be the original point we start from, and this will be simply equal to G02, X value is equal to minus 5, and the Y value is equal to 105.